Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in the previous video, we talked about what is SI unit system, okay? And now in this lecture, we will learn about what are SI prefixes, okay? What are SI prefixes? Prefix. Now, from that name itself, you can understand prefix, something that is already fixed, okay? For simplicity, something that is already fixed. Okay, so let's try to understand, okay, in this lecture, what are these prefixes? Okay, let's try to understand what are SI prefixes. Okay, so before we exactly go into this, okay, let's try to understand few terms over here. Okay, let's try to understand how any physical quantity is represented. Okay, now it's a very simple question. Just ask yourself, how exactly do we represent any physical quantity? Any physical quantity. For example, if I talk about a mass, let's say for example, my mass is, let's say, 90 kg. Just for example, so I can write here that mass M, okay, M is equal to 90 kg, right? For example, just example. Now, when I am writing M equal to 90 kg, okay, here exactly I am not writing 90 kg. What I am writing is M is equal to 90 times 1 kg. Okay, and we know the SI unit for mass is nothing but 1 kg, isn't it? That is the SI unit for mass. Okay, so you can see here my mass is 90 times 1 kg. It is 90 times 1 kg. So here you can see any physical quantity like this mass, any physical quantity, okay, it is represented using two terms. You can see this is first, this is second. So you can see any physical quantity requires two terms to describe it completely. Like you can see here, it requires this number, okay, 90, or maybe your mass is something else, let's say 50, okay, let's say 60, 75, something like that. So every physical quantity requires this number, and this number is called as magnitude of the quantity. It is called as magnitude of the given physical quantity. And the second term that you see here, okay, this one, yeah, I will write here, this is called as the unit, okay, this is called as the unit of given physical quantity. So that means any physical quantity, okay, can be represented as a combination of its magnitude and its unit. Okay, it requires both of these things. You can see magnitude times the unit. Okay, both are actually required over here. Okay, okay. Now over here you will also find out that there are some physical quantities which do not have any unit. Okay, they don't have any unit, they just have the magnitude. Okay, they just have magnitude. That means over here we can say that magnitude is a very important number, or it is a very important term here at a very basic level. Okay, it's very important because it actually tells you about the property of that given physical quantity. I mean, how big, how small, okay, whether it is very, very big, whether it is very, very, very small. Okay, this number tells you everything, isn't it? For example, if I say something like this, let's say mass is 0.000123, something like this, okay, kg. Now you can see here it is 0.000123, okay, times 1 kg. You can see this is the magnitude, and now this number, this magnitude tells me that the mass is very small, isn't it? Here you can see this is about 90. So this number tells me that yes, it is big, isn't it? So that means these numbers, these magnitudes are very important properties of any physical quantity. It tells us about the size, how big, how small, okay, very very big, very very small, okay, something like that. And in fact, some physical quantities don't even have any units, but they will definitely have magnitude. Okay, you check any physical quantity, you will not find out that any physical quantity has units but they don't have any magnitude. That's a joke actually, but actually every physical quantity will have some magnitude. Okay, there are some which does not have units, like for example the refractive index. Okay, you must have heard about this term, refractive index. It is denoted by mu. Okay, this does not have any unit actually. Okay, and there are many more actually, like these. I think like there is a strain. I think you must know strain. Okay, these are again physical quantities. Again, this does not have any magnitude. Oh, sorry, any units. Okay, again, this does not have any unit of measurement. It just has magnitude. Okay, so from this whole discussion, it is clear that every physical quantity must be specified by its magnitude, isn't it? Must have a magnitude. Okay, now if you check every physical quantities, okay, if you check every physical quantities, these physical quantities may have various values actually, different values actually. Okay, for example, if I talk about just, let's say, mass, just mass. Okay, if I just talk about this, so mass, okay, of different objects is definitely going to be different, and you will see that different objects have different masses and the values vary a lot. There is a huge difference. For example, if you see the mass of electron, it is about 9.1 into 10 raised to minus 31 kg. Okay, 9.1 into 10 raised to minus 31 kg. You can imagine how small this is. Minus 31. Imagine this. It's very small. Now, mass of protons, if you see, it's about 1.67, okay, into 10 raised to minus 27 kg. Okay, you can see the difference. Okay, now if I go way ahead of this, let's say mass of any human being, so that would be about, let's say, it's on an average 75 kg. Okay, so now you can see how big this is in comparison to these two masses. Now if I go even further, you can check that mass of the earth is about 6 into 10 raised to 24 kg. Imagine that. Just imagine that. Okay, and even if I go even further, so the mass of our galaxy, okay, mass of our galaxy is about something like 2.2 into 10 raised to 41 kg. Imagine that now. 41 kgs. Just look at this number. Okay, so you can see here that mass of our galaxy, okay, and mass of our electron. Compare these two. Okay, compare these two. You will find out a huge difference. Okay, so what I'm trying to tell you here is that the magnitude of any physical quantity, any given physical quantity like mass, okay, may have a very wide range of values. Okay, the magnitudes of any physical quantity may have a very wide range of values. Like over here, you can see how wide. This is just one galaxy. I have just talked about one galaxy. Imagine universe. How big that would be. how big this number would be. So in fact we can say here that there is a wide range actually, okay, for any physical quantity, a very wide range. Okay, now so since there is a wide range, okay, since there is a wide range, and you can see that some values are very small, okay, and some values are very big, okay, so that's why to represent such values we actually require to use the powers of 10. You can see here we have used the power of 10. Imagine 10 raised to 41. How you will represent that? You have to put 41 zeros in front of this number, okay, 40 zeros actually. So you have to put those many zeros, 40 here, 24 23, sorry, 24, okay. So you can imagine how difficult that would be for us to represent such values. So that's why we use the powers of 10, okay, we use the powers of 10. So now this happens with all the other physical quantities also, okay, all the other physical quantities are also having values, okay, over a very wide range. You check any physical quantity, you check force, you check length, time, okay, you will find out that every physical quantity has a very wide range of magnitudes, okay, and that's why all these physical quantities are represented using these powers of tens, okay, powers of tens, okay. So imagine that suppose you don't have to use these powers of tens, okay, that you see here. Imagine that you don't have to use these powers of tens. Suppose you made, you know, some arrangements, okay, such that you don't have to use them. Instead of using these powers of tens, let's say that you just have some prefixed symbols for each of these powers of tens, okay, you have some already prefixed symbols, okay, for these powers of tens. How good that would be, isn't it? You don't have to write these things, you just have to write the symbol, okay, prefixed symbol. For example, you will have some symbol for 10 raised to 5 or 10 raised to 6 or 10 raised to 9, 10 raised to 10, okay, you may have some symbol for each one of these, okay. So imagine that you don't have to use these powers of tens. Instead you just use some prefixed, okay, prefixed symbols for certain powers of tens, okay, for certain powers of tens. So that would make the representations of these physical quantities and their magnitudes much simpler and convenient for all of us, okay. So that is the main purpose why CGPM, you know CGPM, okay, this is the main purpose why CGPM introduced some prefixed symbols. CGPM introduced some prefixed symbols for certain powers of 10, okay, for certain powers of 10 they introduced, okay, some prefixed symbols, okay. You know CGPM already, they have all these rights to do this, to make any changes regarding units and unit systems. So CGPM actually introduced these prefixes in SI unit systems, okay, they introduced these prefixed symbols in SI unit system, okay. That's why these symbols are called as SI prefix or SI prefixes, okay. These symbols are called as SI prefixes because these symbols were actually introduced by CGPM in SI system of units, okay. So that's why they are SI prefixes, okay. So now Let's actually see which are those prefixes. Remember here that all the powers of tens don't have prefixed symbols like 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, and so on. They all don't have a symbol. Okay, only certain values or certain powers of tens, they have been given some symbols. Okay, so now we will see what are those values or what are those symbols for certain powers of tens. Okay, so we will start with those positive powers of 10 first, then we'll go with the negative powers of 10. Okay, first of all, let's start with positive. Okay, so 10 raised to 1, okay, 10 raised to 1 has been given a prefixed name and it is deca. Okay, it is deca. Okay, you just write the symbol that is small d. Okay, 10 raised to 1 is deca. Then 10 raised to 2 is hecto. Okay, it is hecto. Small h is the symbol for this. Then 10 raised to 3. Okay, see, these are prefixes. Huh? That means for the powers of tens, we have actually given some prefixed names so that we don't have to write these powers, okay, over here in these representation of physical quantities. So 10 raised to 3 is called as kilo. Okay, we already know kilo and it is represented by k. Then after this, there is no 10 raised to 4, no 10 raised to 5. There is no name for that. But for 10 raised to 6, there is a name. Okay, and that is a mega. Okay, it is mega and it has a symbol capital M. Okay, now 10 raised to 9. Okay, there is no 7, no 8, directly 9, and it is called as giga. Okay, it is called as giga and it has a symbol capital G. Okay, now next one is 10 raised to 12, and this 10 raised to 12 has a name of tera. Okay, it has a name of tera and it has a symbol capital T. Definitely you have heard about these two, giga and tera. Okay, your mobile data, okay, your computer memory, isn't it? Gigabytes, terabytes. Okay, generally nowadays laptops have a memory of terabytes, 1 TB, 2 TB. Okay, gigabyte, GB. Okay, mobile recharge, you do mobile recharge 1.5 GB per day. Okay, something like that. You have heard about this. So when they say 1.5 GB, that means it's a 1.5 gigabytes. Okay, that means 10 raised to 9 bytes. And when you say terabytes, that means it's actually 10 raised to 12 bytes of memory. Okay, so that is what we mean. Also, you have seen mega also. Mega, like MB, you know, photos are in MB, like 5 MB. So it is actually 10 raised to 6 bytes. Okay, when you say MB. Kilobytes, here you can see KB. Okay, so these are some prefixes. Then also there is 10 raised to 15. Okay, that is called as peta. Okay, we represent by capital P. Okay, then we also have 10 raised to 18. Okay, which has a name of exa. Okay, this is a prefixed name and its symbol is capital E. Okay, so these are some positive powers of tens and these are the prefixes that are used for them. Okay, these are the prefixes. So for example, let's say the electrical resistance R, okay, is about 6, okay, into 10 raised to 6. Okay, let's say 10 raised to 6 ohms. So instead of writing this 10 raised to 6, we will write this as 6. See here, 10 raised to 6 is what? Mega. So we will just write mega ohm. Okay, so that is how we will write it. Okay, and in that way, similarly, we can use others also. Okay, so these are the positive powers of 10. Now, Now we go to the negative powers. That is, first I will start with 10 raised to minus 1. Okay, this 10 raised to minus 1 also has some name, and it is deci. Okay, deci. We'll represent this by small d. Okay, we'll represent this by small d. Okay, yeah, I think here we have dA, so I'm sorry for that. Okay, it's deca dA. Okay, so 10 raised to minus 1 is deci and its symbol is d. Then after deci we have second one, that is 10 raised to minus 2. This 10 raised to minus 2 is called as centi. Okay, you heard about the centimeter, that is nothing but 10 raised to minus 2. So it is just small c. Then we have 10 raised to minus 3. Okay, and this is called as milli. Okay, this is called as milli, and it has a symbol of small m. Okay, small m. Then we have 10 raised to minus 6, and it is called as micro. Okay, 10 raised to minus 6 is micro, and we just denote it by mu. Okay, micro. Then 10 raised to minus 9. Okay, it is called as nano. Okay, you heard of this name, nano, nanotechnology. Okay, then it has a symbol of small n. Then 10 raised to minus 12, it is called as pico. Okay, so these are the prefixes, pico, and it is written as small p. Then 10 raised to minus 15, it is called as femto. Okay, called as femto. It has a symbol of f. Then we have 10 raised to minus 18. It has a name atto, and it is represented by e. Okay, so these are the prefixes that are actually in use. Okay, actually we use from these mostly we come across this one. Okay, and this kilo. Then over here we come across most of them, especially centimeter. Okay, you know, milli, micro, nano. Okay, we also use this femto a lot actually. Okay, these are also used, but you will see in the course of 2 years that these ones that I have just marked here, these are used a lot. Okay, you will see that these will be used a lot. This mega and this kilo. Kilo is generally used, as we all know, but mega will also be used, okay, in the course actually in lots of the chapters. And here milli is definitely used, micro is used, nano is used, centi is used, femto is also used, you will see in nuclear physics. Okay, so these are the SI prefixes that we actually use. Okay, so I hope everything is clear. Okay, I hope where to use these prefixes is clear to you, how to use it. Just like I have shown here, if it is 10 raised to 6 something, so just instead of 10 raised to 6 we write that mega. Okay, let's say if it was something like this, distance, let's say radius of something is, let's say 1.3 into 10 raised to minus 15 meters. Just an example. So instead of writing this, we will write it like this: 1.3, 10 raised to minus 15 is what? Femtometer. So it is just Fm. So that made it simple, isn't it? So we can use something like this. And there are many other examples, like, yeah, centimeter. If the length is, let's say 12 into 10 raised to minus 2 meters. So instead of writing this, okay, this we will write this one, that is centi. So L will be equal to 12 centimeters. And there are many other examples, okay, that you will generally see. Okay, so again, I hope everything is pretty clear to you. Okay, if you still have any doubts regarding this, if you want to ask anything, share anything, you can share in the comment section. Okay, so thank you so much for joining, thank you so much for listening to me. Okay, so have a nice day. Bye bye, see you in the next video. Okay, thank you.